Hi, today we're going to talk about the conjugate zeros theorem, and this is the last new topic for this unit before our test later this week. And the conjugate zeros theorem is probably something you already knew, but we're just going to put it into formal words. It says, if p of x defines a polynomial function having real coefficients, and if a plus bi is a zero, remember that word zero, it means zero roots, solutions, x-intercepts of p of x, then a conjugate a minus bi is also a zero of p of x. So basically, if I tell you a root of the function of a function is 4 minus I, then you can assume also it has the root 4 plus I. And we can actually write that simplified 4 plus or minus I. I could also say if I give you 4 plus I, then you should know 4 minus I is also a root. They go together. I also just want to remind you of the sum and product of the roots formulas because we'll need that for today's lesson. So we learned this last unit, but remember if you find the sum of roots, so for example, the sum of 4 minus I and 4 plus I would be 4 and 4 is 8. The i's would cancel. So it would equal 8 over 1. 8 would be the negative b, and 1 in the denominator would be 8, would be the a value, excuse me. Similarly, if I were to find the product of roots by just multiplying these two out, FOIL, distribute, whatever you'd like to use to remind yourself of how to remind those things, or how to multiply those things, would be fine. And if you find their product, that answer would be C over A. And then if you took these A, B, and C values, you could write it as a quadratic. That's a skill we'll be talking about today as well. So let's get to our first example over here. Again, feel free to pause the video and copy down anything anytime you need to. So for this example, we need to find a polynomial, in other words, write an equation that satisfies these requirements here. We have to have real coefficients, so not imaginary numbers in front of the x values, of least possible degree having a 0 of 2, so it's going to cross the x-axis at 2, and the multiplicity is going to be 3. A 0 of 3, so it's going to cross the x-axis at 0 with a multiplicity of 2, and a 0 of I, of single multiplicity. So let's start out with the 2 and the 0 because those are the easiest to do. If it has a root, a 0 of 2 with multiplicity 3, well, think about where that came from. If we have a root of 2, that comes from x minus 2. If the multiplicity is 3, that's just that up there, the exponent. So you guys can see that if you were to solve for this root, take the x minus 2 equal to 0, you'd get x is 2. For the next one, if we have a root at x equals 0, you could say that came from x minus 0, but that's just x minus 0, but it's a little bit strange just because we don't write x minus 0. It's just going to be x. And since the multiplicity is 2, we'll write x squared. And now finally we have a 0 of I. And by the conjugate zeros theorem, we know that it's really plus minus I, because if you have an imaginary root, that means that if you have a positive I, you've got the negative as well. If I had 2 plus I, I'd have 2 minus I as well. So now when it comes to the imaginary roots, that's where we're going to use the sum and product of the roots formula in order to get to an equation like this, or a factored form. So if I find the sum of the roots, the sum would be, I plus the negative I. Well, that equals 0. And to put a whole number over 1, that would tell me that the b value, or the negative b, is 0 over a, which is 1. Now we've got to find the product of the roots. The product would be, again, just I times negative I. If I multiplied I times negative I would get negative I squared. You add the exponents. And we know I squared is negative 1. So if I bring down this negative and replace I squared with its equivalent negative 1, that would equal 1. over 1, C over A. So now we have our A, B, and C value. A is 1, B is 0. If negative B is 0, well, positive B is also 0. And the C value is 1. So I can write an equation, again, in the form ax squared plus bx plus c, where a is 1, so 1x squared, or just x squared. There's a 0 in place of b, so just skip that one, plus c plus 1. Now I'm just going to rearrange that so it looks better. I'm going to put the monomial term in front, and then these two can go next. And I'll set that equal to 0 since we're talking about finding roots. So that would be the polynomial that I'm looking for. Now this would be in factored form. If I wanted to write it in standard form, I would just take x minus 2, write it out 3 times, multiply it through. That gets a little messy with this one, so I think I'd rather just leave it in factored form. We can try another one now. And if you're feeling confident, go ahead and stop the video. See if you could do this problem on your own, and then come back when you're done. So we're going to do the same thing. Here we're told that we have a 0 of 1 plus 2i, so by the conjugate roots theorem, we know that it's really 1 plus or minus 2i, okay? And we have a 0 of 2 with multiplicity 2. So once again, let's start with the easiest one first, the root of 2. That one would just be x minus 2 if the multiplicity is 2. We'll make it a square just like that. And for the other root of 1 plus and minus 2i, we'll do the sum and product of the roots. So if I do the sum first, if I do 1 plus 2i and then 1 minus 2i, add the numbers, the real numbers, 1 and 1 make 2. Add the imaginaries, well, they cancel out. So any whole number just put over 1, and that would be my negative b over a. So if negative b is 2, then positive b would be negative 2, and a is 1. Now if I find the product of the roots, 1 plus 2i, 1 minus 2i, we're just going to distribute these or FOIL, however you'd like to say it. 1 times 1 is 1. We'd have minus 2i plus 2i, that would drop out. And last terms would multiply to negative 4i squared. We know I squared is negative 1. So if I just clean that up, negative 4 times negative 1 is positive 4. So the product of roots is just 5. I'll write 5 over 1, and again, that's equivalent to c over a. So now I can write my quadratic out here, knowing that the a value is 1, so 1x squared, or just x squared. Again, if negative b is 2, then positive b would be negative 2, and the c value is positive 5. And once again, this is our factored form. If I wanted to write it in standard form, I would just square this binomial and then multiply these two together. One little thing I wanted to just remind you of is, remember, if the multiplicity is even like this, you would see that the root of 2, so where it crosses the x-axis at 2, it will bounce off like that. It won't go through the 2. When the multiplicity is even, it'll bounce off, not go through. So as another example up here, here the root is 0. If the multiplicity is even, it's going to bounce off the root of 0. Here the multiplicity is odd, and even this one. So for this real root, where the multiplicity is odd, you will see it'll go through the root of 2 because the multiplicity is odd. That's just one little fun fact from what we learned last unit as well. Now your homework for tonight is this right here. Tomorrow I'll post a review assignment for you that'll kind of put together all these theorems we've been talking about, and then I'll post the answers for it later. And again, your test will be given out to Thursday morning. It'll be due back Friday afternoon at 2 p.m. Have a good day.